We at Rotex believe quality begins on the inside and then works its way out. Our foolproof assembly and testing facility for AFSOV and WSSV are our continuous efforts towards achieving the highest degree of excellence. Poka-Yoke 1. Foolproofing of fuel filter screen assembly process. In case an operator forgets to place the M8 filter in the AFSOV casting and he tries to clamp the casting on the fixture, the red indicator light glows and a beep sound is heard. This alerts the operator to place the M8 filter in the casting and fix it with the torque gun. As soon as this process is complete, the beep sound stops. Poka-Yoke 2. Foolproofing of air filter screen assembly process. If the operator directly fixes the air fitting without the air filter and tries to apply torque to the air fitting, the torque gun will not work. This indicates that the operator should place the air filter inside the casting. Now, torque can be applied, thereby allowing him to proceed for further operations. Poka-Yoke 3. Foolproofing of air fitting tightening operation. If an operator forgets to tighten the air fitting and goes ahead with the next operation, he will not be able to apply torque to guide, as he has forgotten to apply torque to the air fitting. The operator has to tighten the air fitting to allow him to apply torque to the guide. Poka-Yoke 4. Foolproofing of guide tightening operation. If the operator forgets to apply torque to the guide and puts the O-ring directly and also the solenoid on it, then while fixing the coil with screw, the torque gun will not work. The operator has to remove the coil and O-ring, then apply the torque to the guide. This allows him to fix the coil with screw and apply torque. As a result, the fixture rotates and allows the operator to go ahead with the next operation. Poka-Yoke 5. Foolproofing of solenoid screws tightening. Unless both the screws tighten to set torque, the assembly does not rotate for the next operation. Also, these screws are captured by a vision sensor for their presence as an additional check. Poka-Yoke 6. Foolproofing of knob tightening operation. Unless both knobs are given torque, the assembly doesn't move to the next operation. Poka-Yoke 7. Foolproofing of pressure sensor tightening operation. Here, the operator hand tightens the pressure sensor, but forgets to apply torque. But when, in the next operation, he tries to apply torque to guide, the torque gun does not operate. Now, the operator has to apply torque to the pressure sensor, and then only will he be able to apply torque to the guide. Poka-yoke 8. Foolproofing of solenoid O-ring assembly, both ASOV and FSOV sides. After assembling the pressure sensor and guide, if the operator forgets to place the O-ring and assembles the solenoid, then the red indicator light will glow and the buzzer will beep to indicate that the O-ring is missing. This is also sensed by the vision sensor. Now, the operator has to remove the coil, place the O-ring, and as he places the O-ring, the red light will turn off and the green light glows. The buzzer will stop as well. Poka-yoke 9. Foolproofing of solenoid interchange. If the FSOV solenoid is assembled on ASOV side or vice versa, then the solenoid cannot be further tested. Even if the operator tries to connect the connectors the other way round due to the location of the female connectors, he will not be able to do so. Poka-yoke 10. All function test 100% check. Test 1. ASOV across port leak test. After clamping the ASOV inlet, 12 bar air pressure is applied through the air fitting. For 30 seconds, pressure decay at the inlet side is measured to calculate the leak. Test 2. ASOV joint leak test. Now, ASOV joint leak test will start. This is nothing but external leakage from solenoid valve assembly to atmosphere. Here, the outlet port is blocked and ASOV solenoid is energized, which will fill the complete volume with pressure. Here too, the leakage is measured through pressure decay at 12 bar. Test 3. ASOV flow test. Now, from ASOV inlet, 1.5 bar pressure is applied and solenoid is energized, keeping the outlet port open. This will allow the air to flow through the ASOV solenoid, which is measured as ASOV flow. Test 4. Pick up and drop down current check. During the flow test, the solenoid is energized with 0.6 amperes for 2 seconds and then it is dropped to 0.23 amperes for 4 seconds. Thus, the reading of the flow is recorded. In case of pickup current higher than 0.6 amperes or drop-down current higher than 0.23 amperes, the flow will be shown as 0 LPM. After this, the current is dropped to 0.12 amperes and the solenoid is expected to close. If the solenoid does not close, it will show airflow and this will be sensed by the flow sensor, indicating an error code through PLC. Test 5. FSOV across the port leak. 12 bar air pressure is applied through fuel inlet port. For 30 seconds, pressure decay at the inlet side is measured to calculate the leak. Test 6. Check valve leak test. Here, the leakage across the check valve is measured with pressure decay method, where 1.5 bar air pressure is supplied to FSOV inlet and outlet port is blocked and both the solenoids are energized. This will allow any leak from the check valve to go to the atmosphere through ASOV inlet port, thus measuring the pressure decay at FSOV inlet side. Test 7. FSOV flow test. During flow test, 1.5 bar pressure is applied to FSOV inlet port and FSOV solenoid is energized and the outlet port is kept open. This will allow the flow sensor to measure the flow through the FSOV solenoid valve. Here also, pick-up and drop-down current parameters are checked as with that of the ASOV side. Marking. There is a serial number and product number marking, which will provide complete traceability of all performance parameters measured during the test. Serial number will not be marked if the valve does not pass all the tests. Also, there will be an error code marking if the valve fails one or more than one test. Thus, when such valves are reworked, they are traceable with these markings. Poka-yoke 11. Avoiding mixing of OK and not OK parts. In case after testing, the solenoid valve is found to be not OK, then the system will not allow the next part to be tested unless the not OK part is put into the rejection chute. Once the part is put into the rejection chute, the error message on screen goes off and the system allows the next part to be tested.